Attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, feu.
Engaged in space research since the early 60s, France had set up a rocket launching site in the Sahara Desert of North Africa to meet the requirements of her national program. With the advent of Algerian independence, she needed to establish a new launch center in order to pursue her space activities. A survey of a number of possible sites led to the selection of French Guiana, an equatorial region, most of which is forest. It's sparsely populated, about 85,000 inhabitants for 90,000 square kilometers. Half the population lives in Cayenne, while there are almost 10,000 inhabitants in Kourou, and the remainder are unevenly scattered among coastal villages and along the rivers. Guyana enjoys a privileged climate. The average temperature is 27 degrees centigrade. The northeast trade winds provide a cooling breeze along its shores. Life is pleasant there. So it was that in 1964, the French National Space Center, the CNES, chose French Guiana as the site of its new operational launch center, the Guiana Space Center. The Guiana Space Center lies close to the equator. When launching eastwards, this privileged location enhances the payload capability of any given launcher, thereby extending satellite lifetime. Facing the Atlantic Ocean, with a launch azimuth angle encompassing about 110 degrees, launch conditions are less constraining, while both polar and equatorial orbits are feasible. The Guiana Space Center was set up at Kourou, in an area which lies between Cayenne and Sinémari. Located between ocean and tropical forest, this center has remarkable range safety assets. The site covers about 900 square kilometers and extends over a 50-kilometer coastal strip. A modern town was needed to cater for the anticipated increase of Kourou's population. Flats and houses were erected around a pedestrian shopping mall. Roads had to be constructed, and 2 bridges were built to span the Cayenne and Kourou rivers. At the mouth of the Kourou River, 150,000 tons of equipment transited through the harbor and industrial area during the first 5 years of the center's construction program. The port provides berths for low-tonnage ships and for pleasure boats. A few years ago, Kourou was connected to the Dégradé-Cannes generating station near Cayenne. The 20,000 kilowatt power plant, which formerly supplied the town and space center, is now used as a backup when launch campaigns are in progress. Telecommunications between the different facilities are carried via a network of underground cables and microwave links, which are complementary and interconnected. The CSG telephone exchange is connected to the Guiana PTT network and is linked up to the international network via the Intelsat and Telecom One satellites. In the industrial area, a liquid oxygen and liquid nitrogen plant produces about 900 tons of liquid oxygen and 3,500 tons of liquid nitrogen annually. These products are stored in cryogenic tanks. It's planned to install a liquid hydrogen plant in Kourou to meet future requirements. The Guiana Space Center officially began operations with the launch of a sounding rocket on the 3rd of April, 1968. Since then, over 400 sounding rockets have been launched from the Guiana Space Center, carrying French or international experiments. In March 1970, the first French Diamant B type launcher lifted off from the Diamant launch site. It orbited the German Dial satellite. A further 7 Diamant launchers put another 6 satellites into orbit. This launching area is now out of commission. Meanwhile, the European Launcher Development Organization, ELDO, was building a launch site for the Europa 2 launcher. Following the F-11 launch failure in 1971, the Europa 2 program was abandoned. At the same time, space techniques were forging ahead in fields such as communications, data transmission, meteorology, Earth observation, and of course not forgetting basic research. The European space industry was growing apace. At that time, only the United States and the Soviet Union had launchers capable of orbiting heavy satellites. It was thus becoming imperative for Europe to have its own launch capabilities in order to achieve the independence required for launching commercial satellites. Europe decided to undertake the Ariane program proposed by France. Overall management of the Ariane development program lay with the European Space Agency, with CNES acting as prime contractor. In 1975, ESA decided to adapt the Europa launch site to Ariane launchings. "50 or so firms from all over Europe are involved in the manufacture of Ariane. France is responsible for manufacturing and assembling the first stage, the third stage, the engines, and the equipment bay. In West Germany, they manufacture and assemble the second stage and the liquid propellant boosters designed for Ariane 4. The solid propellant boosters are built in Italy, and the fairings in Switzerland. These are just a few examples. In 1978, the first Ariane launch site, ELA-1, was ready for testing the fueling of the Ariane 1 type launcher. At the same time, the Guiana Space Centre's operational facilities were being reconfigured and technical personnel were being trained. On the 24th of December 1979, Europe successfully launched the first Ariane 1. Further development launches in 1980 and 1981 led to the launch of India's Apple satellite, the European meteorological satellite Meteosat-2, and the European Maritime Communications Satellite MAREX-A. Since 1982, promotion launches carried out under the aegis of ESA using the Ariane dual launch system SILDA achieved the simultaneous orbiting of AMSAT and the European Communications Satellite ECS-1. Then, successively, two Intelsat-5 international communication satellites were placed in geostationary transfer orbit. The success of Ariane created a requirement for an increased launch capability, so Europe decided to build a second Ariane launch site, ELA-2, with the associated facilities. It was built under the aegis of ESA with CNES as prime contractor. It means that Europe can launch, among others, vehicles of the Ariane 4 family and increases the launch rate to 10 launches a year. Since May 1984, responsibility for launches lies with Ariane Space, a private French joint stock company established in 1980, which numbers as its shareholders, besides the CNES, 36 European firms and 13 banks. Its mission is to commercialize, produce, finance, and launch Ariane. In August 1984, the first Ariane 3 vehicle was launched and put over 2,600 kilos in geostationary transfer orbit. Many spacecraft, be they scientific, communications, or Earth observation satellites, have already been launched, not only for Europe, but also for a number of other countries. the United States, Brazil, and the Arab nations in particular. "20 years after building started in earnest, Kourou has become a real town, numbering over 10,000 inhabitants who enjoy a modern environment economically, socially, and culturally. It boasts a town hall, primary and secondary schools, a hospital, shops, and restaurants. At the tip of the Pointe des Roches, a complex of 2 hotels and 10 bungalows provides 169 air-conditioned rooms for visitors and technical personnel on temporary assignment. Meeting rooms are also available. There's another 40-room hotel in the town itself. Recreational facilities are also provided. There are currently several flights a week from Cayenne-Rochambeau Airport to Europe, the French West Indies, and the Americas. A direct Paris-Cayenne air link connects the 2 cities in 8.5 hours. This is where a launch campaign begins, about 2 months prior to the launch. Satellites arrive by cargo plane with their specific checkout and test equipment. They travel by road to the CSG Technical Center, about 60 kilometers away from the airport. The technical center lies between the town of Kourou and the launch sites. It handles all the activities connected with running the base. It houses the personnel responsible for operations, data acquisition and processing facilities and logistics, the administrative services, the CSG Directorate, and European Space Agency representatives. Within the technical center's perimeter are located 2 buildings of the Payload Preparation Complex, EPCU, where up to 4 satellites at a time can be prepared in exceptionally clean and dust-free rooms, which have a total floor space of about 1,300 square meters. Adjoining these large rooms are other rooms fitted with specialized communication links and plugged into the CSG's closed-circuit television network. They're available to users for setting up their test benches and measuring equipment. Other buildings are located on the Ariane launch site for final satellite preparation. One building caters especially for X-ray inspection of the solid propellant apogee boost motors. It's equipped with an 8 mega-electron-volt linotron for quality checks on the motors prior to assembly with the spacecraft. Another building close by is devoted to pyrotechnical operations and final preparation of the solid propellant motors. A third set of buildings designed to stringent cleanliness standards is assigned to spacecraft fueling, integration of apogee boost motors, and final satellite preparation. These halls can also handle the assembly of 2 spacecraft in the event of tandem launches. A few days before launch, the satellite or satellites are moved to the Ariane launch tower under stringent cleanliness and temperature conditions, either using